The overall goal of the 5G-MoNArch project is to turn the concepts for 5G mobile network architecture into practice. Being part of the 5th generation public-private partnership and funded by the European Commission under the Horizon 2020 framework program, in total 14 partner organizations are contributing to the project. The main challenge for 5G mobile networks are the heterogeneous requirements of vertical industries. These include, for example, scenarios like massive mobile broadband, ultra-reliable low latency communication, or massive machine-type communication. Furthermore, they include a large variety of applications and services such as smart cities, industrial applications, or media and entertainment. However, all those scenarios, applications and services shall run on a common 5G mobile network infrastructure.
In order to be able to efficiently satisfy all these different set of requirements, the technology 5G-MoNArch relies on is network slicing. With network slicing, we have different slices that coexist in the same infrastructure, in such a way that each slice can deploy an independent architecture that can be customized to the specific requirements of the service and can deploy the specific functions that are required in order to provide such service.
Within 5G networks, we have network slicing, and network slicing opens up a whole realm of possibilities for new business models and new stakeholder interactions within 5G networks. And for us, we're trying to understand these new stakeholder relationships, the revenue streams that they open up, the kind of cost of enabling those revenue streams, and the overall business case long term for 5G networks.
So a fundamental feature of network slicing is the coexistence of what we call critical and non-critical services within the same infrastructure. So when it comes to critical services, these are usually associated with industrial applications or with public safety applications, where the main requirement is high reliability as well as high security, since practically we have zero tolerance to any mistake. So how to design these critical services on top of other applications which do not have these requirements is actually the main challenge.
So another challenge that 5G-MoNArch is looking at is how to make use of network slicing when the type of services do not have a stringent type of requirements, and how to make use of the resources in an efficient way, avoiding over-provisioning. So we call this innovation within 5G-MoNArch resource elasticity, and we look at redesigning the internals of network functions while at the same time providing a smart orchestration of the resources both at intra and cross-slice levels.
Network slices are tailored logical networks sharing one common infrastructure. This requires a flexible and adaptive architecture design. To this aim, 5G-MoNArch provides end-to-end solutions spanning from cross-domain, cross-slice management orchestration, data analytics enhanced core network, to a cloud-native protocol stack in the radio access network.
5G-MoNArch will develop two real-life testbeds representing two vertical use cases. Industrial use case in Hamburg seaport and a media and entertainment use case in Turin. In the industrial testbed, the security, resilience and reliability is a critical factor. This use case is located in Hamburg seaport and is focused on use cases such as traffic light control, improved pollution control where a sensor will be mounted on barges, and enhanced security via virtual reality applications. The media and entertainment use case is located in Turin, in one of the historical buildings, Palazzo Madama. In this use case, the important factor is the network elasticity, high throughput and low delays. In this case, the tourist will be connected through 5G radio and will be taken for a virtual, immersive and real-time tour and will be able to interact with the virtual guide.
The central benefits and outcome of 5G-MoNArch are that we enhance and complete the 5G mobile network architecture and show that it is actually usable in practice. We develop features for two main use cases, namely an industrial use case with the Hamburg Smart Seaport and a media and entertainment use case with the Turin touristic city, and implement those use cases into real-world testbeds. With this, we can show and prove that network slicing is actually usable in practice, and we can show that the capabilities of network slicing are sufficient to serve all kinds of vertical scenarios, services and applications without the need for an own dedicated infrastructure for each of them.